Today we're going to look at the last type of factoring strategy. So here's how this is organized. Think what we've done recently. We learned how to factor two-term polynomials with our factoring patterns, right? With our binomial patterns. That's difference of squares, sum of cubes, and difference of cubes. Yesterday we looked at how we factor trinomials, so three-term polynomials, and we just used the same strategy we used way back in Unit 4. Only instead of having x's, we might have like x packets of x squared or x cubed or something, right? But we look for that same type of pattern, trinomial patterns. And you got an assignment where you get some more practice with that. And then finally, the last one is how do we deal with four-term polynomials? Stuff like this, right? They look big and scary, but it's no big deal. I'm going to show you the strategy for this. We'll practice it a little bit, and I'll get you going working on the assignment. So the technique we use is called grouping, factor by grouping. And it does exactly what it sounds like. If we've got a four-term polynomial like this, we're going to write it in standard form. So it goes from the biggest powers of x down to the smallest powers of x. And then after we've tried to factor out any GCF for the whole thing, and there isn't one here, right? Then we're just going to split the polynomial into two groups. First two terms go in the first group. The last two terms go in the last group. Now we're going to focus on the first group. In the first group, we want to undistribute or factor out the greatest common factor. So what could I undistribute from the first group here? X squared. Everybody agree? Give me thumbs on that. Everybody agree? Okay. So we could undistribute an x squared. Now what's left behind if we do that? Okay, I'm going to get x squared times 2x would give me 2x cubed, and x squared times negative 3 would give me negative 3x squared, right? Give me thumbs. We good? Okay, now we want to put a plus sign between the groups, and now we move over to group 2. Now here's the way this works. Group 2 is really easy to deal with. We know that whatever we got for our leftover binomial, after we factored out the GCF, we had this binomial left behind. In order for factoring by grouping to work, we have to have the same binomials left over from both groups, okay? So that means without even thinking about it, I know that this needs to be a 2x minus 3. And that's either going to work or it's not going to work, and we'll see. So we ask ourselves, okay, is there something I could undistribute from group 2 so I would have a 2x minus 3 left behind? Yeah, and we just kind of, the easiest place to look is this first term. 2x times what is negative 6x? Negative 3, right? And now we just have to see if it works for both terms, right? So we would distribute that and just see what happens. If I distribute the negative 3 to the 2x, we get a negative 6x, check. If I distribute the negative 3 to the negative 3, I get a plus 9, and so it worked. So factoring by grouping is going to work this time, okay? Now what? So we've got group 1 and group 2. In group 1, I've got two factors. I've got a red factor and my blue binomial factor. In group 2, I've got this red factor and my blue binomial factor. Now my job is to undistribute the common factor from the two groups. That means the same factor or the shared factor. Well, which one, the red or the blue, is the same in both groups? The blue. It had to be that way, right? We made it that way. So we're going to take the blue and we're going to undistribute that out to the front, factor it out to the front. That 2x minus 3. Okay, now what's left behind? What's left behind from the first group if I undistribute that 2x minus 3? X squared, good. So x squared is what's left from the first group, right? I've got my plus sign in the middle. And then what's left from the second group? Negative 3. Okay, so there's my answer. We're done with the grouping now. If we just clean that up just a little bit, we get 2x minus 3. And how would I say x squared plus negative 3? X squared minus 3. So we're done with grouping. Now the question is just, are we done with the whole thing? Could we go any further with these binomials? Well, that one's done. Could I go further with that one? I can't, can I? We almost can. It looks like it could potentially be an a squared minus b squared type, right? A difference of squares, but the problem is 3 is not a square. If it were a 4 or a 9 or a 16, we'd be fine, but it's not, okay? Give me 1 to 5 on that. Okay, so we're getting there. We need another example though. So there's our answer for this one, okay? Let's try another one. First step. Okay, good. We're going to split up the groups first of all, right? And I would encourage you, I mean, I know this is kind of dorky, but I'd even just make that little line there so you just remember that I got group 1 and group 2, right? Okay, group 1. I could undistribute an 8x cubed. Everybody agree? Okay. So group 1, the GCF is 8x cubed. Now what's going to be left behind here? Cooper, what's going to be left behind? If I undistribute an 8x cubed, what's left behind? X, good. Plus 9. Do I need an x? Just 9. There you go. Good. So 8x cubed times x plus 9. Okay, what am I going to do with the x plus 9? Aubrey, what do I do with this one? Remember, I've got this plus sign between my two groups. Yeah, we just copy it over there, right? It's going to be the same on both sides. So whatever it is here, we got to get the same thing there if this is going to work. And at this point, it may or it may not, right? Okay, so is there, well, ask yourself, what times x squared is, oops, that's supposed to be an x, not an x squared, right? Yeah, there we go. Why don't you tell me that, Gage? No, I didn't hear it. I didn't think you did. So what times x is x? 1. Okay, check it. 1 times x is x. 1 times 9 is 9. Yeah, it works, right? Okay. So now, what's next? Summer, what am I doing next here? Well, I mean, kind of, but I'm trying to undistribute the common factor from each group. So the blue one's the common one, right? The x plus 9. So I'm going to take this guy and I'm going to undistribute it out front. Okay? So that gives me x plus 9. What's left behind if I do that? Okay, 8x cubed plus 1. Yeah, everybody get that? Okay, so we're done grouping, but now could we go any further? We could go further. Which one? The blue one's obviously done because it's just an x, right? What pattern is that red binomial going to fit? Say it again. Sum of cubes. Yeah, so that's the a cubed plus b cubed pattern, right? Okay, let's remind ourselves about that pattern. A cubed plus b cubed. What's that factor into? Minus. Okay, maybe give thumbs on that? That seem good? So then we need to write our 8x cubed. The 1 is pretty easy. The 1 is just going to be, 1 is just 1 cubed, isn't it? Right? But what's going to be cubed? What's our a here? What's being cubed to give us 8x cubed? The quantity 2x. So that's our a, and that's our b, right? So how's this thing going to split up then? There's our pattern. So 8x cubed plus 1. Lucas, how's that going to split up then? What am I going to get there? So my a plus b factor is going to be what in this case? Yeah, there you go, 2x plus 1. Okay, my a squared plus b squared. Well, what's a squared going to be? What am I squaring? 2x, okay. But I'm squaring the whole thing, so what's that going to give me? Ah, good. So I'm going to get 4 times x squared minus a times b would be what? 2x plus b squared, 1. Okay, so that's how the red factor breaks up. And then we've still got that x plus 9 out front that was already done. So there's our answer. Okay? All right, grab a pen, go to a board, try that one. Okay, just so we get this one done for our notes, it looks like everybody was on the right track with this. What's my GCF from group 1? X squared, good. What's left behind? Good. Plus, what do I do next? X minus 8, good. And what's out front? 4, and it checks, doesn't it? 4x minus 32. Okay, so then my final answer is what? X squared plus 4. Now, can I go any further? No, I can't. This one, it looks like you could, but you can't because it's a sum of squares. There's no a squared plus b squared pattern, right? Okay, last one I want to show you here is just one more example. Now, watch carefully what happens in this example. This is really important. This will save you lots of time. So everybody agree in the first group I'm factoring out a 5x squared, okay? Leaving me with, what, x plus 2? Plus, so I need to get an x plus 2 in group 2, right? Okay, so let's see. What times x is 2x? 2. Okay, let's check it and see if it works. So 2 times x is 2x. 2 times 2 is not 6. Look what happened. We got a no-go there, right? So what that means is that this one doesn't factor. Okay, we could just cross this whole thing out. Doesn't factor, okay? How could we have predicted that without having to do all that work, though? Could you just look at the original 4-term polynomial, and just by scanning that, could you tell me, no, that's not going to work? How? You can. Anybody see the trick? Say it again. No, that's not it. There are ways, like if that were a 4x plus 8, it still would have worked. What do you think, Austin?
Has something to do with the 2 not going into the 5 and everything else?
Okay, so it has to do with, exactly, it has to do with this. If I look at the 4 coefficients in order, if I look at the first 2 and the second 2, call the first 2 coefficients in the group 1 A and B, and the two coefficients in the second group, call them C and D. Grouping is only going to work if the ratio of A to B is the same as C to D. If they have the same ratios. In other words, A divided by B would have to equal C divided by D, right? So let's look at an example where it does work. How about this guy? So if I have this polynomial, 8 divided by 72 would need to equal 1 divided by 9, and it does, right? This is just the same as 1/9, and so it does work. Now, sometimes it's hard to reduce these fractions, so an easy trick to see if this actually if these are equal would be to cross multiply. So look what happens here. If I cross multiply, 8 times 9 is 72. 72 times 1 is 72, and those are equal. So this one checks. It does work, right? How about the bottom example? 5 divided by 10 would have to equal 2 divided by 6, which they obviously don't. But if I cross multiply, I can see that also. I'd get 30 on one side, and I'd get 20 on the other, and those are pretty clearly not equal. So that one doesn't work, right? Everybody get that? So you can run this coefficient check. If you can, the factoring by grouping test is just, does the first coefficient divided by the second equal the third divided by the fourth? If yes, go for it. It's going to work. If not, stop. It's not going to work. Okay, give me 1 to 5. How are we doing? Okay, get to work.